Here we are.
Oh, just
So
got beer.
Yeah, it's Stammtisch, Craig. You can have a beer.
Let's see so many and recognize so many faces, and I'm so happy to see a few new names in the chat window, in the window. So for those who are the first time here, just a couple of words on who we are, what we're trying to do. So Paulo started this group about 1 year ago, and I joined soon after with the intention of understanding a bit more what quantum computing is, and most importantly, how it's going to impact the business world. So there are many forums out there which are looking at this from a very technical point of view. All we like to do is try to understand more what is it going to mean for our companies, what is going to change, when it is going to arrive. We must confess we have many more questions than answers, but what we try to do over time is we did try to bring in some experts and help us answer some of those questions. The format we're using today is more of an informal conversation. We'll have a few topics which we are going to explore together. So it's an open mic. If you want to, say something, raise your hand, and we'll give you, we'll open the line for you. And it's more informal and, conversational. Anything you want to add there, Paulo?
No, can you hear me?
We can, yes.
Oh, fantastic. That's a good step.
See your proper name now.
Good. No, that's perfect. Though I do know that if we want deep insight from Craig, we need to get that quite soon, because he's got an even more exciting meeting at 7 o'clock that he needs.
Right. Okay.
I think we should go around and do a quick round of introductions, and then if Craig sort of saved the world in the last month since our last catch up, he can share with us.
Okay.
Do you want to guide us round, Em? We'll get some intros because there's a few new names and faces.
Yeah, I will start. So my name is Em. I'm working in insurance. I'm currently in an innovation role within an insurance company. Passionate about technology in general, curious as a person, and just here because I'm trying to understand a bit more with the help of this community we're trying to build. So next on the screen, I have Charan.
Hi guys, glad to be back.
Oh.
So I work on data sciences, mostly machine learning, natural language processing. I'm here to learn about quantum computing, and I think in the last week after our last meetup, I've written my first quantum computing program using Quantum Development Kit from Microsoft.
Oh, nice.
Yeah.
We want to hear
excited.
everything about it in a second once we finish off the presentation introductions. Next one on the screen is Chris Carney.
Hello, that's me. Yes, I'm not on mute. That's good. I work in insurance too. There's a surprise. My interest is really to understand better what quantum computing can do for us, and certainly then the risks that may relieve and the risks that might create. And obviously then we can start thinking about insurancing the solutions for that. So that's my interest.
Thank you. Thanks, Chris. Next one on my list is Justin.
Hi guys, my name's Justin. I look after Europe, Middle East, Africa for a company called Exceedance, who are a managed services and technology company. I'm just nosy. Just want to have a sort of poke around to see what's going on, really. I think if there's benefit to our organisation and to the wider insurance industry, happy days.
Justin, has Exceedance built a quantum computer yet?
No. It's too hot in India. We can't get down to the required temperatures.
Is it on the roadmap?
No, I don't think so. I mean, I think we're quite an innovative company, but I think that's probably a step too far for us at the moment. But I think, depending on how it all sort of pans out, I can see some really interesting use cases, or I can see that there would be. I'm not sure I've got the imagination to see them myself. But I think in insurance, there must be use cases, and it's just trying to understand what those might be.
Thank you. Craig, you are up next.
Thanks. I'm a partner with Lime Street Digital Partners, which is a firm I founded. And I'm a loss adjuster by trade and been in risk services for 25 years. I think maybe 26, some of which has been in lockdown. And I've looked at quantum for about 4 years as an observer. And it shows some promise as being one of the first technologies that has the potential to figure out our complicated insurance industry.
All right. Thank you. Paulo, you're next.
Yes, good afternoon, good evening, everyone. My name's Paulo Cuomo. I'm an operations guy who always wants to think about how the proven technologies can make operations better, but I'm also naturally interested in the technologies that are 2 or 3 stages out. And I think the question around quantum that I'm keen to work out in these discussions over the coming months is, at what point should anyone be caring, except if, like Justin, they're simply nosy? Because I think that you've got a bunch of people, as we have on this call, who are intellectually nosy about it, but actually what really matters is when it starts to be relevant for the CFOs, the CROs and the lawyers, etc., because that's a sign that I would have a view that whenever the lawyers get involved, then it's probably hitting mainstream. So yeah, really looking forward to insights. I know many of you, I don't know all of you, so looking forward to the discussion. Thanks, Em.
Sure. Before I get to Nicholas, we have a message from in the chat. Pedro is a business management student, used to be in physics, and he left, but he continues to be a nerd and a curious person. So welcome, Pedro. Nicholas, over to you.
Good evening, everybody. I just came across the group. I recognised a few names on it, so I thought I'd be nosy as well and come and see what it was about. I've actually got a 6:30, so I won't even be here as long as Craig, but thank you for letting me just say hello, and I'm just going to listen with interest. Thank you.
Okay, brilliant. Thank you. Rupesh?
Hi, everyone. Rupesh here. My background is in ERP solution designing, mainly doing like business analyst kind of roles. And lately I've been kind of very fascinated by the world of blockchain, but then from there it transferred across to quantum computing. And my interest has kind of since grown into that area and see how quantum computing can assist with the betterment of Earth, basically socially as well. So again, newcomer, trying to learn more about this topic.
Brilliant, thank you. And Rumli, you're next.
Hi guys, I am in cybersecurity, so mainly focused on emerging tech. So quantum is one of them, and you may remember me from the first on-site quantum meetup, but I didn't join you on the second one, and this is the third one. So yeah, mainly curiosity and how quantum computing will impact the cybersecurity industry. So that's my interest.
All right, thank you so much. We have another Paulo. I'm wondering if it's the same Paulo. I don't know. It probably is.
Yeah, it's 2 of me. Sorry.
There's only one, Paulo.
And finally, Meek, nice to see you again. You might be on mute, Meek. Yeah, there you are.
I am. Hi, how you doing? Sorry, I'm on a shop run, so I'm just coming back. So I'm not largely in luck mode. It's good to see you all again.
All right, brilliant. Thank you. So we prepared a bunch of questions to just keep the conversation going. I'm reading them out loud. Let's see if these make sense to us.
And
so
before we do the questions, should we hear from Sharon's coding experience?
Mm-hmm. Yeah, let's do that.
Okay.
So the question is, who's got coding experience, right?
Yeah, it was not much. To be honest, I was just looking at some YouTube videos, and then it took me a while to decide on what to use. IBM, there is something from dwave, and there is something from Microsoft. So it took me almost a few hours to decide on Microsoft in the end, because of the entire experience it comes with. I haven't really delved into the code much deeper. It's been mostly the Hello World program and then some random number generator. So it runs on a simulator altogether. So it doesn't really connect to a quantum computer. It's mostly about exploring the toolkit, what it provides, and trying to understand what a qubit is. I think I understand it, but I'm still not sure. Like I really get it. So I'm still trying to understand. Like I'm in the initial phases.
And is it interoperate with Azure?
No. It's going to be interoperability with Azure once they do a public preview or something. Right now, it runs on a simulator just on your laptop.
All right. Okay.
The promise that they
do they say what they're aiming to do? Yeah, is it just, as you say, IBM, dwave, Microsoft, they all want to start to get in people's minds as the place to go? Do they try and differentiate themselves in any way?
From what I've seen is IBM and dwave lets you run your programs on not on demand, but in a queue system or something on their quantum computers. You get some kind of credits, I guess, from what I've read. Maybe those blogs could be old. Whereas Microsoft, they don't have any hardware which we can run on yet. But the promise that they give is that your programs are going to be ready to be run on a hardware when they're available on Azure. So that's what they have.
So that's a classical quantum hybrid plan?
I don't know.
Okay.
Not sure.
Cool. Well done for trying anyway. That's pretty cool.
Yeah. So a question that brings a question, right? So if it's can be simulated, how does that work? I don't get it. If you're doing hello world, fine, but if you're getting something more complex, how does that work in a simulation? I'm not sure. Whilst, you know, the IBM, they give you the actual thing you can run things on, so you get the full power in theory.
I think the quantum number generator is the clue, right?
Mm-hmm.
I think that's the simulator.
Right. Okay. So I was saying earlier, we got a bunch of questions to try to get the conversation going. So first one is, are we going about this all wrong? Is thinking about quantum computing as a next wave of classical computing risking missing out on the potential? Did I read it right, Paulo? You want to elaborate on that question, maybe?
Well, I'm intrigued to see how people interpret the question, but essentially, if we think right back to the discussion we were having last year where we were challenging each other and saying, is a quantum computer simply the same as being able to use the entire AWS processing power on your own for half an hour? Or is it something fundamentally different? My sense is that most of us intellectually are still at the point that it's just a really, really big computer rather than it's something fundamentally different. And it'd be interesting to know whether the group thinks that that's absolutely fine to think that it's just a big computer because there's enough big computer problems that we need to solve, or whether actually we need to be starting from scratch with effectively a different question set. I don't know if people have got thoughts on that.
So my understanding, again, I'm not expert, but my understanding is the things you can solve is a completely different classes of problems. So my understanding is not like a classical computer on steroids. It is a different thing, solving different things. So you will need specific algorithms to be run there, which are, you know, probabilistic algorithms. So it's not just AWS times X. It is something different, and it's only useful for those specific classes of problems where you have to, you know, calculate those probabilities or running, you know, at the same time. That's my understanding as from a non-expert point of view.
From what I've listened to, I think the end game in this is you probably could build a general purpose quantum computer at some point in the future, but why would you use it for everyday tasks? That's just, you use it, its benefit comes from, you know, its ability to do specific things incredibly well. And so running one as a generalistic computer, PC or whatever is never going to happen, or it will be a terrible waste of a resource.
Hi, Alex.
You'll be using it to attack difficult problems, protein folding and, you know, all those sorts of good things. And that's where its strength will be. It's just another tool that's been created that does things really efficiently that today we find incredibly difficult to do.
Yeah,
Craig, you send us an
I agree
interest.
with that. I mean, I think, you know, there will end up probably being standard, well, for the foreseeable future anyway, standard computers and quantum computers, because they're going to be presumably quite rare and tremendously expensive to build and to run. And I think if you look far enough in the future, they kind of replace everything. But short term, why would you do something that doesn't require massive computing power to do, you know, standard tasks? But that I think is coming from a point which is what Paulo raised. Am I just thinking about it as a really clever computer rather than, you know, I mean, there may be problems that it can solve that we haven't even thought of yet. I don't know.
I think that's at the heart of it, and I think Chris is absolutely right that there's a natural next step of I don't know, talking about protein folding and saying, you know, that's just so impractical on a normal computer that arguably it is a entirely different use case, not just something that we could do in 3 or 4 years anyway on a normal computer.
Yeah,
I think, but what I guess I'm getting at that point, which is, are the use cases we're defining simply those things, a little bit to Craig's introduction when he says maybe quantum computing can solve some of you know, some of the questions in insurance. Are they just the thing that we've been trying to solve with big computers and realize we can't? Or do we need to try somehow and blank our minds there and go back to asking questions that we've not even tried to ask in previous lives?
right. So rather than saying, actually, with quantum computing, we can do cat modeling in 10 seconds rather than it taking 24 hours, actually, we've just got to think of it completely differently and think, well, you know, what else can we do with a quantum computer that, you know, that is totally, you know, no one's thought of at the moment.
Yeah, I mean, I put it to IBM because I was chairing it sounds all very grand. I was chairing a conference a couple of years ago, and IBM came and did their song and dance, and they were showcasing Watson and a movie that where all of the artifacts of the movie were put into Watson, and it then created a 60 or 90 second trailer. And so one of the things I was told during the conference by the organizers that appointed me was not to upset the sponsor. So that's not a thing you would normally want to say to me, really. So I was using Slido for the Q&A part, and when IBM were up telling everybody how wonderful they were with their artificial intelligence and Watson and all of that, I had to log out of Slido, log in with a fake ID, put the question I really wanted to put to them back into Slido, and it went to the top of the list. If Watson is so clever, why doesn't it unpick your AS400 stuff and recomposite your data in a way that we can all use it? And that didn't go down very well, but it was popular with the audience. But they were the first ones to put a computer in insurance, right? What is it, 1940? I don't know, like 1950 something. I think it was what is John Hancock now? And that was the first computer to make it in. And if you go to the Imperial College, the Science Museum, they have a great exhibition now of all the first early computers, including the first AI and pattern recognition machines. And the first insurance computer is there as one of the centerpieces. And the original life calculator is there. So with all of those things, and you can start commingling lots of risk factors to look at risk in a different way. I think that will be one of the early outcomes. I think we've seen some promise with the COVID-19 open research projects. They felt that this is a really good way to road test quantum technology over other traditional forms of research. The folding at home shows how distributed computing can be brought to bear. So there's lots of things where this is going to crystallize, and it's a bit hard to predict where it's going to be, but they're ultimately research projects at the beginning, and you never know. Your hypothesis is never always right. So who knows where it's going to end up, and I don't think we're having the wrong conversation at all. It's just our version of the conversation. But I like the analogy that we had at the live event, the first live event, and I think Runley, it was you remember this one as well. It was the flipping of the coin analogy and trying to understand a qubit. When you flip a coin, you think of, we have a binary in and out, and then if you put a coin in the air and while it's spinning in the air, the heads or tails thing, that's how the processing works. So I thought that was a great analogy. It does everything at once.
But I think also as well, I wouldn't underestimate the impact of just being able to do something like a capital model in 5 minutes.
Oh no.
Or 3 seconds. Like the fact that you can just, even doing things that are very computationally expensive now, being able to turn that around and iterate on them really quickly can have very far-reaching consequences. You know, and it doesn't sound very interesting or sexy or revolutionary, but in many ways it can be, just because all of a sudden we can now look at, you know, 50 different capital models and decide on our bit. I'm just talking specifically in insurance here, but that alone, to me, just the massive increase, like, you know, orders of magnitude increase in improvements in computational time can be quite revolutionary.
Or I also think it's that the opportunity of having more type of unique algorithms that are available for people to kind of have their individual use cases. So for the enterprises, like we are saying that for insurance industry, or it could be for automotive industry with self-driving vehicles and even communication and security side of things. So things like, you know, like finding the best possible way of going, because quantum QC won't allow us to get like a definitive answer, but it will be very highly probabilistic answer. So that kind of, you know, gives you a steer into which direction we should be either investing money, energy, or time, I would say. And in terms like, you know, some of the use cases that comes into mind, even from insurance perspective, I don't have an insurance background, but I'm just thinking out loud here, is where people are, you know, the digital assets that are currently being stored. And with the advent of QC, where Peter Shor's algorithm is proving to be quite a challenge for imploding the RSA cryptography, you know, that kind of thing, you know, it will probably speed up the process of cracking that kind of cipher security model that an organization currently has in place. So where organizations are holding that kind of information will be quite critical, because now you find so many algorithms which are like post QC. So once the QC is out there, you know, we need to start protecting our digital assets right now with the algorithm that cannot be cracked using QC kind of power. So I think it will be, you know, it has a kind of knock-on impact even before it has arrived, I think, from business perspective.
So my take is, I think it's probably in the middle. So I think there will be things we are doing now, for which we will find new algorithms which will be able to be executed on quantum computers, which will give, you know, reduce the computational time, which also means you can expand the complexity, right? If let's say you are doing 1,000 variables today, you will be able to do 1 million, I don't know. That's that. So stuff we do now, done better and faster, provided that we find the right equivalent algorithms, and then things we haven't even thought of at the moment. I think truth is in the middle. You will have both of them.
Like parallel processing as well. Like, you know, currently, in order for us, like AWS or any kind of cloud offering that is currently available, the parallel processing, it's also very limited. Whereas with the analogy that Craig and Rudy might have given is that the spinning coin, whereby, you know, at any given time you have the ability to process so many different types of variables in one go, rather than executing multiple functional routines in a classical model. So, you know, obviously, apart from saving time, it also saves the designing of systems much more smaller, quicker, less expensive in terms of energy it consumes, the cost it has for every time you do an query into QC. You know, it has got so much benefit in that area, I would suggest.
Thank you, Rupesh. Anyone else wants to add a bit more on this one?
I want to build on all those and just think back to what Mick said, because I remember discussions in modeling in insurance back when we were moving to the cloud, whatever it was, 10 or 12 years ago in the first place. And I remember almost exactly that, someone saying the ability to run models in a few hours rather than overnight allows us to ask different questions. And so from that point of view, they were saying that it wasn't just the fact that it was now 5 or 10 times faster, but the fact that it was 5 or 10 times faster allowed a paradigm shift in what you needed to do. And I guess it's almost a little bit like, and let's see if this analogy works, having an Airfix model versus a box of Lego blocks. No, it doesn't work. But I think where I'm trying to go is instead of saying we've got a limited amount of computational power and therefore we need to define the question clearly, our hypothesis clearly, and just see what comes out, we can now sort of test and learn and refine. Now, my challenge is that, and I like Craig's background now, I can just see it as, you know, he gets consumed by the quantum computer. The challenge I see is that we'll use that as a lazy way of not really thinking about how things could change, but we'll spend the next 2, 5, 10 years just getting excited about asking a slightly different set of questions, not about being fundamentally different. But hey, let's hope that not everyone is as narrow-minded as me.
But to be fair on that, Paulo, I mean, for all new technology, whenever you look at it, the new technology is always, you know, the new version of the old. So like I was reading an article about today, the great example was like when news media first went onto the web, they tried to put ads beside the content, like, you know, like newspapers did, it didn't really work. But then Facebook and Google and the digital native companies invented the news feed, and they started putting ads inside the news feed, and suddenly it's worth more now than print media ever was. So I think if you start to see people adopting the technology, you'll start to see technology native applications coming through then. But you don't, it's always almost impossible to predict that stuff in advance. You don't, you know, basically until we know better, we always just try to make a faster horse. And there's probably just because there's such a massive cone on uncertainty. We don't really know any of this stuff until we're actually at the coalface, and that's when we start to figure out the native stuff.
Yeah.
I think that, you know, in my mind, the lack of progress is probably because it's a technology looking for a problem. So the problem hasn't been properly defined, and the current classical computing is able to deal with most of our problems. And I know technology sometimes have to run ahead of the curve, but it's just there's a complete lack of definition of the problems we're trying to solve.
Yeah, and I think that fits a little bit to Mick's idea of cones of uncertainty there, because we're still right at the beginning of it. We're just thinking faster horse.
I guess one of the issues is there aren't enough people who understand quantum, and this is why this group is incredibly valuable. There aren't enough people who understand quantum computing and the seismic changes that could bring, who can then think about what the business problems are that quantum can solve. So at the moment, you're right, we're just thinking, you know, we can run models faster, and there's a huge value in that, I agree. But it's not moving the dial. I mean, it might move the dial, but it's not changing the landscape. We're not thinking, well, actually, how about we completely change how we model? No, that's quite different. That's quite different. Suddenly you've got a different landscape.
Now that maybe segues nicely into another point we wondered in people's opinions, and Craig, you've already touched on this, which was there was obviously a little bit of people jumping on bandwagons, whatever it was, 7 or 8 weeks ago, saying, "Hey, we'll give our quantum."
A huge tub of spaghetti bolognese.
Oh, someone's forgotten to switch on mute. Oh, really? That was getting exciting. So 7 or 8 weeks ago, people jumping on the bandwagon saying, "Hey, use our quantum computer to solve the COVID problems, to work out what it is, to work out an antidote, etc., etc." Craig, you touched on that. I don't know if people have a sense of whether that's got anywhere or was merely a PR effort by the various QC companies.
I think I've just been trying to catch up with the news on that, actually, which is why I put that link in on that dwave systems thing. They donated a lot of this, and what I have seen so far is the folding at home, but I'm not up to date with the quantum effort.
Cool.
The folding at home thing has delivered some really impressive results, though. I mean,
is that like we all put SETI on our computers 15 years ago, but didn't find any aliens?
Yeah, but in this case, you're putting GPU power on. So a company, a broker pal of mine, also an ex-Imperial AI masters, I think he got. During COVID, he put all of his business computing power onto folding at home from his broker cluster setup. So he donated all available GPU power to the effort, because he insures doctors and frontline clinics and all of that sort of thing. Along with his quote and bind business, he was also doing, in the background, his computers were working around the clock to try and help solve the puzzle. And they gradually worked their way up the ranking in terms of all of the contributions and success that they'd made in modeling this thing. There's a great video on it, actually, showing the computer composite of COVID-19 as a result. So they can now study it in an objectified way to solve the puzzle.
I can remember from many years ago, a distributed computing thing for looking for cancer drugs, I think, a long time ago. It was, again, looking for, I think it's called ligandfit.
Yeah, I think it's part of the World Community Grid. I have it as my screensaver, and it runs loads of different projects. You just run it as your screensaver, and it takes up all your
that's right,
your transient bandwidth or
idle
compute
time.
power.
Yeah, I remember that well. I'm not sure it works on Macs now, but yeah, it was good.
Do we know of the various quantum computers scattered around? Presumably, are at full capacity with stuff whether paid for or people using a few free credits queuing up. So there's not.
D-Wave's the only one with commercial installations, as I understand it. They're the only ones that have got, and there seems to be some debate on how many bits of power they got, but there's some that are in the defense industry, of course. Jet Propulsion Labs have got them. There's this, I think, of course, CERN and others. So there's, but the ones that are fully commercialized, I believe, and I'm happy to be wrong about this, I guess first is D-Wave and coming is Hitachi. Is that right? Or Honeywell?
Honeywell announced the other day, didn't they?
Yeah, Honeywell is working with like Goldman Sachs in order to do with their quantitative analysis part of things right now.
But the D-Wave proposition is quantum in a box, right? So they actually turn up with the kit and put it in your building.
Yeah, annealing technology, yes.
Yeah.
So how many installations are there?
Sorry, Justin?
I was wondering how many installations there actually are.
Well, half of them I can't talk about, but I think 9 at last count.
Okay.
And I think, is it, I think
I saw
50 qubits.
Something like, I saw D-Wave, one of the head guys at D-Wave spoke in Dublin a couple of years ago, and I think they had mentioned, like Google, FedEx, I think Postal Service, and there was like 4 commercial, and like you said, then there was like a bunch that were heavily NDA'd that they couldn't talk about.
And it's a Canadian company, so I have absolute pride in that.
There is one in Oxford University. Sorry, go ahead.
No, you go ahead. I was just making one about, I think they were bought by Alphabet, weren't they, D-Wave? But by the by.
I was going to say there's one in Oxford University, and I met the guy at one of the exhibitions, and yeah, he showed me some pictures.
Will you come into a chat, Runley?
Pardon?
Will you join us for a call, do you think?
I can ask.
Well, please do. I think that'd be a great contribution to hear from a practitioner and to work those ideas back and forth, just so we create a bit more domain knowledge.
Yeah, I'll find out.
Fantastic. That would be great. Absolutely.
And I think we can, open this to anyone. If you got people, experts in the field you would like to bring in, we will be happy to, make the connection. So connect with them and invite them. If you have names to put forward, please do reach out to myself or Paulo.
Okay.
Should we touch on the third theme, Em?
Absolutely. So today's Twitter hack was likely a social engineering event. Does it and similar incidents undermine efforts by quantum security firms to push their technologies if it will always be to the human in the loop that lets things down?
I vote for always human in the loop.
Yeah. I've done, a bit of security back in the days when I was at uni, and there was they said, the human factor is the ultimate security loophole.
The problem there, though, is that dealing with humans doesn't scale very well. Whereas if you can deploy quantum computing against RSA or whatever public key cryptography, you can just scale it, and you can bring down everything then.
So the question, Mick, was actually, I think, the other way around to your point is valid, which is, so we had a webinar the other day with a chap from Quantum Exchange, and there've been, various other discussions about, protecting data at rest through quantum, protecting through quantum photonics for your communication of your keys, etc. And all of that sounds very funky and very expensive. So I have this vision that someone decides to build a quantum secure setup. It can fight off any quantum computer attacks and can fight off people tapping into fiber cables. And then some muppet called Fred gives away the password because he gets flirted with on social media. So I'm just
I get that, but where I was coming from was that if they have a bigger bazooka, then you don't need the human element anymore, because you can just hack it. The Theodosian walls don't work anymore because the Ottomans are coming with cannon, and all of a sudden it does, and you don't need to rely on the Muppets. You'll always have the Muppets, but if I can just say, well, I don't need to get one person in 50, I can just blow through the walls of all 50.
Yeah.
So it becomes I think it's the arms race that will drive that kind of thing.
Yeah, I think, Paulo, what you're getting at is fight quantum with quantum, right?
Well, I'm wondering,
I mean, that's kind of where you're at, right? Is you need quantum to defend against quantum.
Yeah.
And as I understand it, I mean, this is where I got really, shall I say, I got really kind of confused with the business of that company we did have on, until I got to they're applying quantum communications is already, and it's one of these things like the Internet of Things. If we're not careful with the terminologies, we're going to confuse everybody right off the bat. And we're using quantum technology for security to secure things. Actually, they're using a quantum number generator to encrypt packets over the internet. That's what they're really doing. It's an appliance. It just lays in a quantum number into a thing that only another machine at the other end does it. It hardens it. It doesn't solve it. It doesn't defend against a quantum attack. But I really get it, and I think that's why they've adjusted the Bitcoin blockchain to resist. So it's quantum resistant. I don't think they're saying quantum proof, but quantum resistant. And I think our friend on the call also said that 2048 encryption was easier for quantum to hack than 4096, which I thought was a fairly logical conclusion. But you know, it's just that RSA key of 128 bits encryption just keeps scaling up and scaling up to be more and more complicated. Quantum will overcome that a lot faster. And I think as a bad actor risk, it's huge. I mean, they're telling me on the news here that all of the research projects in the United States, Canada, and the UK have now been hacked by Russians. All of the COVID projects.
And I think
they've lifted all the research.
The other great point we mentioned a couple of times, and John Briscoe was making, was this idea of harvest today and decrypt tomorrow. That's also, you know, quite dangerous to hear. Right? You call just.
Sorry, say that once more time, Em. I didn't quite.
So John Briscoe has this concept. John Briscoe, the guy from Quantum Exchange we did speak a few weeks back, he had this concept of harvest today and decrypt tomorrow. So I think there's now a lot of attacks. People just get the data, even if it's encrypted, they gather it over the internet, and then they have them in-house, and you know, when quantum comes available to them, they will just
lift it, shift it, break it up later.
Yeah.
Yeah, absolutely. No question. You just grab it and then, you know, tuck it away, and at some point in time you work out how to get into it. That's
it's just
the nature of the game now. And you can't really protect yourself against state actors because they've got the resources to throw at this stuff I'm talking about today that no individual has. So, you know, you're going to get hacked if they want to. If they want to get you, you're going to get hacked.
Well, I think as Monty Python used to tell us all Canadians that we're all lumberjacks, right? And we cut down trees and we wore high heels. And but I mean, it is classically what you're talking about in a very lay term, Em, I think, is that you're going around cutting down the forest. You don't cut down the forest, chop the logs, split the wood, put them in the pile and leave them there. You drag them somewhere and set them up and let them season before you set fire to them.
Well, and it's interesting, right? Because to your point, Craig, and I'd heard a news snippet. I hadn't heard as much as you'd shared in terms of the scale of the hack. But you know, if this was 18 months ago, I'm sure the majority of those organisations that have been hacked now didn't believe that they would ever be doing something that was interesting enough to being hacked. You know, this probably isn't just the Novartises or whoever are doing, you know, super valuable R&D for the next billion-dollar blockbuster. This will be university labs and stuff who sort of figured they were at doing the type of work that just wasn't interesting in and of itself. So they probably didn't even imagine they needed to strengthen themselves against those type of hacks you're describing.
Well, going back to your Muppet thing, it turns out that a few exchange students from PRC were in Canadian labs and were arrested on departure from Canada.
There we go. Gets interesting.
There's your Muppets.
Well, no, they're probably the smart ones, aren't they? It was the people who didn't put two and two together. Should we do a whiz round to see if people have got any sort of thoughts or news that we haven't touched on, plus any feelings of what would be good in terms of speakers or ideas for the next few months?
I got an interesting one to share. So I came across this article a couple of weeks back where basically it was around build your own quantum computing at home. So apparently there is like a bit of movement of people building small devices with parts available in the market. We're talking about, I don't know, 10, 20,000. Clearly they don't have the scale and the power of, you know, the big labs and, you know, the micro Kelvin precision, including them down. But it's interesting to see that this movement coming up. And it reminds me of, you know, the garage era from the 70s where there were, you know, the IBM of the like having their big mainframes, and then someone in a small garage came up with a personal computer. I'm not saying this is going to happen, but it's an interesting parallel I've seen in the news a couple of weeks back.
So I saw that. I didn't even bother reading the article because I just thought it was an idiot journalist who didn't realise that it had to go down to such a low temperature.
So they were using other technologies like, you know, photons, which you can do without having, you know, and clearly, again, they don't have the scale. You won't be able to run anything significant on it. But it's interesting to see there is this movement of people building their own little machines on the side. You will never know, right? If you do small things on a huge scale, a lot of number of people doing it, who knows? You might come up with some good groundbreaking ideas.
Essentially where Apple came from, isn't it?
Exactly, yeah, that's the parallel, interesting parallel I was trying to draw there.
It's funny, I was listening to a podcast just a day or two ago, I can't even remember who was bemoaning the lack of garages for middle America these days, because you know, no youngster can afford to have a house with a garage, so how are they supposed to create the next Apple or Microsoft or whatever?
Well, now they'll be doing it in a bedsit.
On the balcony. Just touching on that, this, I think, an interesting point actually for some point over the next few months is this question around temperature. Now, you know, clearly if you're using a fundamentally different technology like photonics, then it isn't relevant. But some of the news that's percolating out about inverted commas classical quantum computing, so, you know, the standard quantum computing, but no longer needing to be at whatever 0.1 Kelvin. I've just no idea technically how that works, because everything I've read over the last few years talked about the need to be really, really cold for any of the physics to work. So yeah, it's going to be interesting if anyone's got a view of that.
I don't know, but I suspect that it all boils down to, you know, how do you sift your way through the errors? You know, if you could control the number of errors you've got, and that probably means having more qubits to hand. Once you've got the ability to control that, you can start to raise the temperature, because that's obviously going to be the primary thing that drives your error rate, right? So the more qubits you have, the more error correction you can have, the warmer it can go. I guess. I mean, that's probably certain one factor to it anyway.
That would certainly make sense, yeah.
No, there's a bit of that, but I think there's also the technology they're using is slightly different and it's able to operate at higher temperatures. It's a combination of the two things from what I remember.
Cool. Anything else from your side, Chris? Any new news or topics you'd find interesting for the future?
No, I had a little bit of a sort of a nose around before this, and nothing really new has come up. I've seen, as you know, sort of the main sort of quantum platform providers giving their time away for COVID-19 research, but other than that, I haven't seen much come up of late. Not certainly anything new.
Cool. Justin, anything from your side?
No, you know me, Paulo. I just take it all in. Don't give much back, I'm afraid. I will one day, I promise you.
One day, you're saving it all up, yeah. All right. Well, one day we're back in town, and you can buy us all beers.
There we go. There we go.
Craig, anything from your side?
Yeah, I still haven't mastered the mute button. No, I haven't much to report because I've been in a busy situation.
Good. And part of your busy situation, Craig, was a hackathon. At what point will we be doing quantum computing hackathons, do you think?
I think there has been one.
There was some online IBM thing, wasn't there, 6 months or so ago?
Yeah.
And I think in the last meeting I shared a link as well to their pilot system. I guess, Charan, you'll have found it. I think they're starting out with Tetris or something like that, the quantum version of Tetris. So you can program that up.
Yeah, and Sudoku.
I noticed from our InsurTech community that one of the co-founders of an InsurTech has started a coding YouTube channel during lockdown, and I've been finding it very interesting because it actually works at all levels. You know, it's just learn a bit of Python, learn a bit of this, learn a bit of that, and it's quite well done, very effective. I'll try and share the link in just a second.
Excellent.
That'd be great, yeah.
Cool. Sharan, anything else from your side?
No, not much.
Cool. Good luck with your experiments. We look forward to hearing how it goes when you move beyond Hello World.
Yeah, when can you show us? I mean, come on, share your screen, show us what you got.
Yeah, absolutely, yeah.
Let's see it, come on.
Not now, maybe next time.
Next
all
time,
right,
we'll
next
prepare
time.
you next time. We need to see it. Hello World, and then we want some flashing lights or something, yeah?
Definitely.
With a flipping coin, with a flipping coin.
He's worried that we're going to flirt with him and get his password. That's the problem.
No, I'm on my work laptop, so that's the one.
And then initiate a global Bitcoin scam on Twitter.
I'm intrigued to find out over the next few days how many people did send their Bitcoin details to Elon Musk. It is intriguing.
Well, presumably there's a log on it. I mean, it'll be on the ledger. You'll be able to see all of it.
Yeah.
Cool. Rupesh, anything from your side?
Sorry, not from my side at the moment. I'm just pretty curious about next time around. For sure, I will be able to contribute more.
Absolutely fantastic. And obviously, you know, drop us an email or a LinkedIn note if you've got thoughts on speakers or questions and stuff. Look forward to that. Runli, anything from you?
So I remember there's this exhibition, the same exhibition when I met Peter from Oxford University. And they had this, rather than superconducting quantum computers, they had this, I think it's called trapped ions. And, you know, I always wanted to know a bit more about that and how that's different, because that's not subject to any temperature restriction. So yeah, perhaps someone, if you have knowledge of that, you could share. And another thing is, with all the links shared in there, I'm on a phone, so if you could just share in the email with all the relevant links for today.
What I'll do is I'll post them onto LinkedIn then, so you'll find them on the Quantum London LinkedIn page either this evening or tomorrow morning.
Okay, cool. Thank you.
Perfect, thank you. Pedro, anything? We'll assume not.
Yeah. Or put it in the chat, Pedro.
Yeah,
If you don't
of
want
course,
to
he was on chat only. Sorry, Pedro. Mick, last but by no means least, have you returned from your shopping trip yet?
I have. That's sorry. And just as you asked me to join, I went from 3G to my local Wi-Fi, which is why I went quiet, which was perfect. I've timed this perfectly this evening at every level. No, I was just thinking, I know Michael and Jerry, they're my co-founders. They did a tour with the DIT across a couple of companies in Northern England. And I think they spoke to a university guy who's involved with quantum computing. So I'll hit Michael up tomorrow to see who that guy was and see if he'd be interested in talking to us.
That'd be fantastic.
Michael,
really
from what I remember, now this is a vague man, I may have got my details backwards, but I seem to remember him something like that, and he was quite a nice guy and interesting. So I'll see what Michael has to say about that, and I'll let you know.
Please.
Appreciate it. Cool. Fine. So yeah,
I just put a Twitter link in that maybe some of you might want to follow, which sort of follows on from our Innovate UK speaker that we had. But this is the EPSRC, imaginatively named Twitter account for the Research Council, and which is looking after the UK's interest in quantum computing and quantum security.
Cool. Thanks, Craig.
Cool.
Sure, we'll post all these. The plan will be to have a similar discussion this in a month or so. Hopefully between now and then we'll have one or two speakers, either as sort of a live webinar or a sort of offline podcast or webinar or something. So keep the suggestions of people, either specific names or just general topics coming, and Em and I will do what we can to convene those sessions.
Yeah.
Excellent. Good.
Cool.
All right.
Final thoughts, Em? Or we good to go?
No, just, thanks everyone for joining us tonight. It's always a pleasure, to have a bit of a chit chat around these topics. And again, if you got people to want to put forward for future events, just let us know. We'll make it happen. We'll try to make it happen.
Thank you for organizing, Em.
Thank you for organizing.
And Paulo.
Yeah.
It's a pleasure.
Thanks,
Thank
and
you.
thanks,
Bye.
Paula.
Thank you,
Thank you.
everyone.
See you all.
Bye bye.
Nice to see you all healthy as well.
You too. Take care.
Cheerio.
Have a good week. Bye.
Bye.